Hi everybody, good morning and welcome to the Windows Azure storage session. Today with me again, Niall Moran will be our guest speaker for the session. Don't forget, next week on the 22nd and 24th of October, we will have the remaining two sessions from the series around infrastructure as a service and application development on Azure. Niall, good morning.
Good morning, Miguel. Thanks very much for that. And welcome everybody. Thanks again for coming along so early. With a bit of sunshine this morning, which is great to see. Okay, as Miguel said, today we're going to look at storage, and this is the second part of a four-part series that we're doing on Azure. Next Tuesday we'll look at some infrastructure services, and next Thursday we'll look at application development on Azure. So by way of an agenda for today, we'll have a quick look at storage accounts and what they are, what they mean. We'll have a look at a number of different ways of storing data within Azure, blobs, tables, and SQL Azure. And we'll then move on and have a look at some disaster recovery solutions. And we'll do a demo then with some, again, disaster recovery solutions with SQL Azure, as well as System Center Data Protection Manager. Any questions you have as we go, please feel free to enter them into the IM window. I'm actually sharing my desktop, so I'm not going to see that, but Miguel will collate those questions and we'll do our best to answer them at the end of the session. So when it comes to storing data in Azure, you have a choice of 8 data centers across 3 regions, the US, Europe, and Asia. Within your Azure subscription, you can have 20 different storage accounts, each with 100 terabytes of data and each tied to a specific region. The data within the data center is replicated 3 times to ensure resilience against any hardware failures. And if you want to, you can choose to have your data geo-replicated to another data center within the same region. The regions are US, Europe, and Asia. Each storage account can be used to store unstructured files or blobs, which are binary large objects, tables, which are NoSQL key value databases, and queues for messaging applications. All of this makes Azure storage great for quite a few use cases, including web assets like images, scripts, or media files, backup solutions that will ensure your backups are replicated across data centers, and applications that require fast and highly scalable non-relational databases instead of relational databases, which can be difficult and expensive to scale. We can use our storage accounts for highly resilient virtualized disks for your VMs and highly scalable messaging applications that communicate with other applications or users via queues. When it comes to accessing data stored in Azure, you have a number of options. Files stored in blob storage will have unique URLs which can be restricted based on a secret key or a schedule, meaning that files can be shared for a defined time period. Files can also be made public so that they can be embedded into a website or application. If you do this, you can customize the URLs by associating custom domains and creating CNAME records in your domain registry. As with most services in Azure, data can be accessed via the REST API and the many SDKs that have been developed in languages like .NET, Node.js, PHP, Java, Python, and Ruby. This allows you to access your storage account via code, maybe to upload files, display images or video, store or process messages, or read data from a NoSQL database table. It's also possible to write scripts that interact with your storage account using PowerShell commandlets. This is very useful if you want to publish data to Azure from on-premise systems for backup, or to integrate an on-premise legacy application with a cloud application via a queue. There are also a number of storage explorers that can be used to manipulate the storage accounts. Visual Studio is best for developers that need to have a quick and simple access to storage accounts, so they can be integrated easily into their custom software solutions. There are some links in this PowerPoint, and as always, we will make these available at the end of all of the sessions so that you can get at these links. Okay, let's take a look at how blobs are stored, or binary large objects. Essentially, blobs are stored in containers, and each container defines the permission levels for the blobs within it. You can't create containers within containers, so be careful of thinking of these containers as folders. If you want to create a folder structure for your blobs, you can do this by changing the name of a blob once uploaded and incorporating a path separator within the name. So changing the name of a blob from, say, background.jpg to images/background.jpg would allow you to access that blob within that folder. And that allows you to use Azure to store your web assets, but adhere to a structure that you define. There are actually two types of blobs you should know about. Block blobs, which are optimized for streaming. The blobs can be split into multiple blocks and uploaded and downloaded block by block. So block blobs are the default type and used primarily for files. Page blobs, which are optimized for random read-write operations, which provide the ability to write to a range of bytes in a blob. And these are the basis of virtual hard drives that are used with your virtual machines. You can see the URL there for a blob is based on the account, the storage account, which is tied to a specific region. And it's also based on the container and the name of the blob. So as I said before, you can build in any hierarchy into that by including the path separator into the blob name. When it comes to storing data, a relational database like SQL Server or Oracle is often the first choice. And when you're working with transactional systems that manipulate a lot of structured and highly relational data, then a relational database is absolutely the right choice. However, if your data doesn't require a lot of structure and relationships, or has no defined schema, then a NoSQL database can be a better choice. One type of NoSQL database is a key value database, just like an Azure table, which represents a collection of entities. The interesting thing is that no schema is enforced, so each entity can store different attributes. This means that entities are independent of each other and have no relationships. This makes for very fast read access and supports massive scale internet-based database applications. Azure tables have a concept of partitions that allow you to group entities together within a table. Within the partition, each entity will have a primary key, but partitions are required to provide this massive scalability. Essentially, Azure load balances requests across partition servers, which means you can improve the scalability of your application by partitioning your data. I know from speaking to a number of my customers that this area can be confusing, as a lot of people think Azure tables in the same way they think of SQL Server tables. But it's important you don't think of them that way. They are not cheap, highly scalable replacement for building out a relational database like SQL Server or Azure SQL Database. Instead, consider the data you're storing within your application and whether or not a relational or NoSQL approach is most appropriate, or of course a combination of both. Typical scenarios where tables may be used would be metadata for other storage types like files, settings for applications, or a product catalog where the product attributes may be different depending on the product. So we talked about tables as being a NoSQL database solution, but what about relational databases? You can of course build out your own SQL Server cluster in Azure using infrastructure services, and we'll look at this more closely next week. But to do this, you need to manage everything from the virtual machines to the failover and load balancing, as well as the licensing. So before doing that, you should consider SQL Azure Database, which is based on the same SQL Server technology you're used to, but provided as a service that is designed to be highly available and to scale automatically to meet demand. Within SQL Azure Database, we currently have two levels, web and business. With web, you can create databases up to 5 gig, making it perfect for small workloads. And with standard, you can create databases up to 150 gig, making it perfect for larger workloads. It's important to point out that web and business both are multi-tenanted shared services, meaning the underlying infrastructure is shared by everyone that uses the service. This may make it difficult to accurately predict performance for your workloads. That's not to say you won't get excellent performance, but predicting and guaranteeing it may be difficult. The good news though is that because this is a shared service, you'll only pay for the storage that you use and not the storage that you reserve. If this is an issue, then we have a new premium offering, which is currently in preview. This will allow you to reserve capacity for your database, allowing you to accurately predict performance. The cost for this reserve capacity will, however, be significantly higher. It's worth pointing out that SQL Azure Database is part of our PaaS solution, which means you provision your database, connect to it in a similar way to any other SQL server, and all the headaches with managing servers, mirroring or clustering are taken away. So I'd strongly recommend you look at it before building out your own SQL Server infrastructure on-premise or within IaaS. Just a quick note on securing access to your SQL database. Sorry, we just jumped ahead there for a second for some reason. Rather than using a REST API like the other Azure storage services, SQL Database is accessed via a table data stream, the same protocol used by SQL Server, operating over port 1433. To help protect the data, SQL Database Firewall prevents all access to your SQL Database server until you specify which computers have permission. Initially, all access to your SQL Database server is blocked by the SQL Database Firewall. Connection attempts originating from the Internet or Windows Azure will not be able to reach your database server. In order to begin using the SQL Database, you must go to the SQL Database portal and specify one or more firewall settings that enable access to your SQL Database server. It's also worth mentioning that to access your database at an application level, SQL authentication is only supported, so there is no Windows integrated authentication. If Windows authentication is required, for example in a SharePoint implementation, then you must build out your own SQL Server VMs. Apologies for that slide, it must have been on automatic rather than click. Okay, so I want to talk about some backup and disaster recovery scenarios. This is an area that when I talk to customers, they're really interested in using Azure for backup and disaster recovery. Azure Blob support REST APIs, so you can use it directly and build tools to integrate. But there are several ways you can use Windows Azure Storage to integrate with your on-premise data center environment. StorSimple is a cloud integrated storage solution which combines the data management functions of primary storage, backup, archive and disaster recovery with seamless Windows Azure integration, enabling a hybrid cloud storage solution through a single system and Windows Azure. The StorSimple system uses Azure as an automated storage tier, offloading capacity management burdens and ongoing capital costs while providing enterprise-grade local performance for active datasets. Using local and cloud snapshots, application-consistent backups complete in a fraction of the time needed by traditional backup systems, while reducing the amount of data transferred and stored in the cloud. Cloud-based and location-independent disaster recovery allows customers to recover their data from virtually any location with an internet connection and test their DR plans without impacting production systems and applications. Thin restore from data in the cloud enables users to resume operations after a disaster much faster than possible with physical tape or cloud-based tape methods used with other cloud providers. Windows Azure Backup helps protect server data against loss and corruption by enabling backup to off-site cloud storage in Azure. It provides a consistent experience for configuring, monitoring and recovering backups across local disk and cloud storage, integrating with the backup program in Windows Server 2012 and System Center 2012 Data Protection Manager. Azure Backup encrypts and protects your backups in offsite cloud storage with Windows Azure, adding a layer of protection in case of data loss or disaster recovery. So let's take a look at how Azure Backup works in more detail, starting with how to use Azure Backup today in a small business environment or a branch office. If you have a small number of servers and you want to protect the data they hold using built-in tools, the process to configure Azure Backup is relatively simple. First, you need to sign up for an Azure account. This will provide you access to the Windows Azure management portal. From there, you can select recovery services and add Windows Azure Backup to your account. The next step involves installing an agent on the server or service that you want to register to use Azure Backup. As mentioned, the Windows Azure Backup Agent integrates with the existing Windows Server Backup tool. And when you start the tool after the agent installation, you register this server using a certificate. Then you can configure whatever data you want to back up and schedule the way you want it to be backed up. And that's it. So if you're using a schedule, the server will now back up your data to that schedule. You can monitor it from the backup tool to see when the backup ran, when the next one will run, and view any issues. If you need to recover data at any time, for example, a server failure, or even an accidental deletion of a file or folder from a location being protected, you can use the backup tool to recover that data. Windows Azure Backup provides you very granular recovery options, either to the original server or a different one. This can also be done with Data Protection Manager, which is part of the System Center suite. So again, first we would sign up for an Azure account. We can install our agent on the DPM server. We can register and configure. So the Windows Azure Backup Agent integrates with DPM. And when you restart DPM after the tool has been installed, you register the server using a certificate. DPM server will continue to protect the existing server as it did before the agent was installed, but the server will now back up the data to the cloud. Again, if you need to recover data at any time, for example, a server failure or an accidental deletion of a file, you can use DPM to recover that data while still continuing to monitor and protect the other servers. The first stage in the transfer process is the encryption of your data on-premise using your key. Your data stays encrypted with your key while in transit over the wire to Windows Azure. Your data stays encrypted while it's in Azure. It is never decrypted while it resides in Azure. Your data can only be decrypted once it's restored on-premise, and only you have the decryption key. This makes it very important to protect this key. Make sure you back it up, keep it safe, and store a copy off-site. Your data cannot be decrypted without it. In the event of key loss, Microsoft cannot help you. Microsoft does not keep a copy of your key and has no access to it. The key is never passed to Azure during any Windows Azure backup. And this is really important from the point of view of disaster recovery and storing data in the cloud. Okay, I'm going to switch over to my browser. We're going to have a look at a couple of scenarios from a demo point of view, specifically around disaster recovery. The first one I want to look at actually is SQL Azure Database, because I'm often asked the question with SQL Azure Database, do I need to back up my SQL Azure Database? And I guess my answer to that is always yes. So I want to show you some of the tools that you can use to do that. So when you create a SQL Azure database, you create it in a specific data center. And within that data center, the data is replicated 3 times, and that database will be highly resilient, highly available, highly scalable. However, in the case of disaster, we always recommend that you back that database up. Now, a really easy way to back up a SQL Azure database is using the export function here. And this will allow me to export my database to a Blob storage container. And the important point here is if I set my storage account up to use geo-replication, I can be confident then that my database is being backed up not only to the same data center, but to a second data center as well. So I'm just going to kick off that export and let that work away. Once we've actually backed up a database, just to show you that we can actually create a database, a second database, by importing a backup. So I'm going to select a backup that I created earlier this morning. And I'm going to choose the server. And I can even create a new database server. So the point here is that I can restore this backup to a completely different region. So I'm going to restore that to West Europe. Now, manually backing up databases like that is useful, but if we click into our SQL database and click on Configure, you'll see that we can automate that backup schedule as well. So again, I can select a storage account, I can define the frequency, and I can define a retention policy for backups as well. So this is a enterprise scale backup solution. And again, remember that as we store these backups into a storage account, we have the option of geo-replication as well. A final point, if we have two servers, if we've restored a database backup to a different region, we can even sync databases. So we can set up some sync schedules to sync between two databases. We can use this to sync between two databases in SQL Azure, or even to sync SQL Azure Database back to an on-premise SQL Server database. Okay, the second demo I want to show you today is how we can back up on-premise data to Azure. And the way I'm going to show you this is using System Center Data Protection Manager. So the first thing I'm going to do is I'm going down to my recovery services. And you can see there that I've got a recovery service called Niles DPM Backup. This is a backup vault. Oh, and that's we'll just recreate that one. That was one I deleted earlier. So when we create a vault, set the region. So I'm going to choose West Europe, and I'm going to create that vault. Now, in order to encrypt the transfer of data from on-premise up to this vault, I'll need to upload a certificate, which will handle that encryption. So as soon as this vault has been created, I'll upload a certificate. Now, apologies for all the flicking. I'm actually having to share my desktop, so I'm flicking between different things. So there I've just uploaded the certificate. And that's done. Now, once we've done that, we're ready to actually set up our Data Protection Manager hooks into that vault. So I'm going to switch back to my Data Protection Manager. So this is my on-premise DPM. And in here I've set up a protection group called DB Backups, and I'm using this protection group to back up some database servers that I've got on premise. Now, before I can do anything with Azure Backup, I need to go back in and I need to register that vault that I've just created. I'm going to browse for the certificate. So this is the certificate that I uploaded. I can encrypt the connection now to Azure, and I can see that vault that I just created. We can throttle the bandwidth that DPM has access to when it's uploading backups to Azure. I can enter a location for recovery. And I can generate my passphrase. I mentioned this earlier on. This is really important. So this is the passphrase that's going to be used to encrypt your backups. You can define it or you can generate one. Microsoft have no knowledge of this passphrase, so make sure to copy it and store it securely, because this is what's used to encrypt your data at rest in Azure. And we'll just register that now. Once I've done that, I'll go back to my protection group and I can simply add online protection to it. I can define my retention policy, I can define my scheduling, and I can update the group, and that's it. So now my existing Data Protection Manager protection groups will also be backed up to Azure in the cloud. So, in summary, Azure Storage provides a highly scalable and durable solution for a number of scenarios, including file and media storage, NoSQL databases, as well as on-premise backup and disaster recovery solutions. Again, if you want to get started with Azure, you have a free trial option. If you've got an MSDN subscription, you'll have some usage within that, or you can talk to your account manager. From a learning point of view, the training kit, Virtual Academy are great resources for demos, presentations, and video content. If you want to keep up to date on new changes with Azure, we have a new release coming out in a couple of weeks. You can follow my blog where I blog regularly about new changes and new features.